Hey, welcome back to my garage. In this video we're going to be doing the bench testing of the Centroid CNC software, setting it all up. There's some things that we need to do to Windows 10 first. There's a link below in the description to Centroid's YouTube channel where one of their techs, Leave goes over setting up CNC 11 on a Windows 10 box and the things that you need to do to Windows 10. Also, I'm going to throw in a little clip about Windows Smart Screen. With that, let's get going. Okay, so we're going to be using the installation manual for the All-in-One DC. We're starting at section 2.2, the All-in-One DC setup, and we're going to follow this manual step by step. So one of the things that you need a shielded Ethernet cable. You can tell a shielded cable from a non-shielded one is there's a metal jacket around the connector, and there's not on a non-shielded one. Here's my cable, and you can see that it's a shielded cable. And the first thing it's asking us to do is connect the Ethernet cable to the All-in-One DC and to our computer. So let's go ahead and do that. And if you have any other accessories that you might have bought, like a manual pulse generator, a jog panel pendant, you go ahead and connect them to the All-in-One DC here. The next thing it tells you to do is wire the power supply. They used to use PC-based power supplies. They don't do that anymore. They're using these Meanwell power supplies. It's an RQ-65D. It should have come with your All-in-One DC. There are specific instructions on wiring it in the manual, and here they are. The red wire goes to the 5-volt terminal, and here's the 5-volt terminal on the power supply, and then green is ground, and that goes to common, and it comes with a jumper already on it and goes to the chassis ground. And then minus V4 is blue, that's this one, and then there's the minus V4 on the power supply, that's the negative 12 volts. And then the other one's yellow, and it goes to the positive 12 volts on the power supply. Now, it's nice to know that you have 24 volts here on the power supply. It's a 1 amp output up to an amp. So if you need to drive a 24 volt relay or something like that, it's kind of nice to know that you have that on the power supply. And then they ask you to hook up your line and your neutral. In my case, because I'm bench testing right now, I just got a 2-wire power cable, hot to L, and the neutral, the rib conductor of these cords. There's a rib on them, if you didn't know that. One of them is smooth, that's the hot, and then the one with the rib is the neutral. So with that, that's all hooked up, and so my power supply is hooked up. And then this Molex connector, it says logic power. It gets plugged in right here. Okay, so that's our power supply. I've already got my encoders wired up. That's the next section in the manual, is to get your encoders all wired up per their instructions, and they recommend a 2000 count encoder. So in quadrature you'll have 8,000 pulses per revolution. Centroid does sell the encoders. They're differential and incremental encoders. The All-in-One DC uses DC incremental quadrature encoders. So the differential has a companion channel, an A, the A plus, and then the A minus, the B plus and the B minus, and then the Z plus and the Z minus. That's a differential encoder. Here's the chart right here, and then the pin number for the DB9. I've already showed in another video wiring up my encoders and refitting my servo motor, so we're done with this section. And it says power up the All-in-One DC, so let's do that. Actually, you know, I'm going to take the cover off the All-in-One DC so that in the video it'd be easier for you guys to see things. You should do all this testing on a wooden bench, a non-conductive surface, not on anything that's cloth covered, because some fabrics can conduct and have static electricity in them. That wouldn't be a good thing. And then I definitely avoid plastic tabletops for the same reason, because they can be charged with static and you don't want to blow up your new all-in-one DC controller. Alright, so there's the all-in-one DC under its panel. Let's go ahead and power up all-in-one DC per the manual. And it looks like it's starting to come to life. You can see the LEDs doing its things, blinking 4. Let's see what the manual says about that. It says LEDs showing the status of the all-in-one DC. That's all these LEDs. And then right at the very top there's 2 LEDs there. They're the 12 volts, minus 12 volt and positive 12 volt LEDs. Those just telling you that the voltage is good there. The positive 12 volt and the negative 12 volt are used in the analog spindle speed output. Check the LEDs initialized as defined below in the table of LED states. If any of the LEDs are not initialized properly, check Appendix C for the troubleshooting step. So far, so good. We're getting the DSP debug. That's this other LED over here. It's flashing at 1 time per second. Otherwise, everything is a solid green. Drive fault, status of the drive fault relay. That's this last one here. It says turns off after communications is established with the software and all faults are cleared. Well, we don't have the computer set up yet, so we're not there yet. So that LED is going to stay on. After about 15 to 30 seconds after the all-in-one DC is started up, LED 1 will display a number. If the 7-segment display is displaying a solid number without a decimal point, it indicates the drive bus order as seen in figure 2.43. That's this one here. Indicates a drive bus order as seen in figure 2.43. If LED 1 is flashing with a decimal point, it indicates an error shown in figure 2.44 here, and it's flashing. If you have a blinking 4, that means the all-in-one DC is not seeing limit switches. Since we've not hooked up limit switches yet, you can disable them using switch 4 as pictured in 2.45, and that's right here. Here's the limit switches, and they are right next to the Ethernet port, so we'll disable them. Okay, they are now disabled, and you notice that we have a solid 1. We've got a solid 1 now showing in the display. LED 1 will always display a 1. A table of other drive errors and their definitions is provided below. So that's down here in the manual. All right, so Chapter 3 is the Windows software pre-installation. It's a Windows 10 configuration for use with Centroid CNC software and hardware. So you can follow that. Levy, their technician, goes through setting up Windows. I've got Windows 10 set up, but I have not yet installed the software, the CNC software. And I'll go ahead and show you that as well. Okay. I'm going to go ahead and install my software, the CNC 11 software, the latest version. There's a link in the manual under the software installation, so you want to get the latest version. I'm going to go ahead and unzip it now, extract it. Watch my other video for the PC build. I go over building the PC for Centroid's software using their minimum system requirements, which isn't a lot. I think I built this computer for about, I want to say it was $300. So you know, I bought the motherboard, and it's a Celeron processor, 4 mega RAM. I'm sorry, 4 gig of RAM, and then I got a 120 gig solid state drive, and then I bought an inexpensive PC case for everything to build it. It was a pretty straightforward build. Ironically, I had a problem with my solid state drive, so I had to get it replaced. But then got it taken care of, got Windows 10 loaded up on it, and per Centroid's video, I've got Windows 10 and all configured properly to run the software. I mean, you know, the computer itself is driving a machine, it's running a machine. You don't want it to do anything else. On the rare occasion that Centroid support needs to get to your computer, you'll want to have TeamViewer 12 installed, or the latest version of TeamViewer, so they can remote access your computer, and then they can go through and check your configuration. When you buy an all-in-one DC, you get, I think it's a couple hours of tech support to help you out if you can't get through it, which is a really cool feature. I've worked with Centroid in the past before on a TeamViewer session, and they've got some really sharp technicians. They get in there and they get out. You know, one thing that they can't do is, obviously, they're just looking at your software and your configuration. They can't account for any wiring mistakes or misconfigurations in your hardware. So, you know what you're doing when you're setting up your hardware. Looks like we're almost done. And I've had nothing but good support from Centroid. Okay, so it is on the desktop here, and we're going to go to Setup.
The very first window here that pops up is Windows doesn't recognize the Centroid CNC software. You're going to hit More Info and click Run Anyways. So I'm running the setup.exe.
Here we go. We agree. We're doing a mill. We're not doing the demo. We're doing a live mill. I encourage you to do the demo version if you want to just explore the software on another machine, or look at Intercon, their conversational program, if you want to look at that on another machine. I believe you can do that as well. So we're doing a mill. Click Next. We're going to accept the default directory. Let it install all of its files. Alright, that's done. Next. Network adapter setup. Alright, this is the network adapter in my computer, and there's a Wi-Fi. I've got a USB stick here, but this is the one that we're going to set up. So it has to have a static IP address. That's one of the reasons why you want to get your all-in-one DC powered up, and you want that Ethernet cable plugged in between the all-in-one DC and your computer, so it can help you set this stuff up a little bit easier than manually going in there like LeeView talks about in the video. So we're going to go with that. Yes. And we're going to go to Finish. Would you like to install PLC program at this time? Yes, it's a fresh install. We're doing an all-in-one DC. We're not doing any ATCs. We're not doing anything that's custom. These are all custom things. We're not doing that, so we're going with basic. This is installing programmable logic controller. Installation is complete. Alright, so the software is installed. We've got a CNC mill logo here. Now we're going to go ahead and restart the computer, and I'm going to go ahead and power down all-in-one DC just in case. And I'll be right back with you. Okay, I'm back from the reboot. So we're at Chapter 4, the bench test, 4.1 software configuration. Let's go ahead and start this. And what you should have been met with is enter your software unlock demo codes or your codes. I've already installed my unlocks, but let me show you where they're at. They're in F7 utility. F8 option, and here's where they're at. So you can see my intercon software unlock is on, my demo is unlocked, and my permanent unlock is on. You would have been prompted to enter your unlocks. That would have come with your board when you ordered the package, your all-in-one DC. You would have got a sheet with your unlocks, and you would have entered the codes. You would have hit F1 unlock option, you would have picked which one you're working on, and then you would have entered the code. So the next step is, did you install the correct PLC program? And on this screen, F7, F8, F1, the unlock option, this time this option screen should contain some additional information. Look for the box labeled MPU PLC as shown in 412. Well, that's in the middle of the screen on the left. This is MPU PLC. And it should read all-in-one DC-basic-v2.src, and mine does because I'm doing a mill. So we're good there. And then if you have, then it says number 3, install other unlocks. So we're done with that. Now, before we move on, earlier in the video I defeated my limit switches on the all-in-one DC by flipping the dip switches off. I've turned them back on because we're going to need them when we do this next section. So if you turn them off, turn them back on. Those I think there's 8 of them. 2, 4, 6, 8. Yeah, 8 switches. They're to the left of the Ethernet connector on your all-in-one DC. Turn them back on. All right. So change machine home type. Navigate to the control panel as seen as 413 from the main screen. So we're going to get out of this. Main screen, F1 setup, F3 config, 137, and then we want F1 control, and here's where it would say machine home at power up. It tells you to toggle it. Mine was at home. It says toggle it to jog, and then the next one is jog panel required. Initially it comes set up this way saying yes. You want to turn it off to no. So you should machine home at power up should say jog for the test, and jog panel required no. And then you save this. And then after saving, press escape, go back to the main screen and shut down. Okay, we're back from the restart. So I am on disable PLC faults for limit switches, loop, spindle, e-stop, and axis faults. I was reading this, and you recall earlier in the video that I had flipped the limit switch disable dip switches on the all-in-one DC. Those are the bank of 8 dip switches to the left of the Ethernet connection. I've since turned them all back to the way they came from the factory so that this section applies, so that what we're looking at on the diagnostic screen is correct with where we're at in the manual. So anyway, we're going to do an Alt-I, disable PLC faults for limit switches, loop, spindle, e-stop, and axis faults. At the main screen, press Alt-I to bring up the real-time AIO display. This is a great diagnostic tool, by the way. You can see all the what inputs and outputs are active or not active here. Using the arrow keys, move the selection box to the top left of the inputs. We're moving to the top left, and it should read input 1 AX 1 _ minus limit OK. That box is down about 2/3 of the way down in white, not a box, but that dialog. It says INP1 AX1 minus limit OK. What that is it's describing, you see as I'm scrolling, input 9, input 10 spindle inverter OK, input 11 e-stop OK, input 12 spindle range. So that gives you a descriptor of these inputs and outputs, what they're currently assigned to. So we're back up at 1. So we are asked to invert the input, so it's a Control-Alt-I, and that inverted 1. And we're going to invert number 2, 3, 4. Says to do 1 through 11 and 17 through 20. That's number 10. That's number 11. Here's 7, 17, 18, 19, and 20. You will notice that the LEDs will turn from red to green and a line will be drawn over the top to indicate that it is in a state. It is the state of the input has been programmatically inverted. So that's what we've done. Note, using Control, Alt, and I simultaneously to disable I/O only works for those using the latest version of the default Centroid provided PLC program, which I'm working with. Now we're going to label the axis. So we're going to get out of this. It's done. Alt-I. And we're going from the main menu F1, F3, 137, F2, machine, F2 motor. Under label, it says label your axis. Mill is a typical setup for a mill is axis 1 is X, axis 2 is Y, and axis 3 is Z, and they are set that way. So we're good there. If you have an unused axis, it should be set to N or no. So we're good there. Let's label the axis. Configure drive bus assignment. The CNC 11 software needs to be configured to know where each axis of the all-in-one DC is. The all-in-one DC is using something called drive bus to communicate with the CNC 11 software. For a 3-axis mill, all-in-one DC axis 1, labeled axis 1 on the all-in-one DC drive cover, should be configured as drive bus channel 1. All-in-one DC axis 2 should be configured as drive bus channel 2. These parameters can be reached by pressing the F1 setup. So we need to get back to setup. So F1 setup, F3 config, 137, enter. Press F3 parameters, F8 next table until we get to 300. 300 is 1, 301 is 2, 303 is 3. 300 is 1, 301 is 2, and 302 is 3. Yep. Unused axes need to be set to 0 or errors will occur, and the others are 0. Configure the encoder assignment. Just like in the previous step, the CNC 11 software needs to be configured to know where each encoder of the all-in-one DC is. Unlike the previous step, the all-in-one DC does not use drive bus to allow the encoder to communicate. Instead, the all-in-one DC uses the onboard MPU 11 encoder channels via parameters 308 to 315. For a 3-axis mill, parameter 308 is 1. There it is. 309 is 2. 310 is 3. Unused encoders can be left as is. They do not need to be set to 0. Disable spindle axis. Disable the spindle errors by disabling the spindle in the parameters. The machine parameter menu can be reached by pressing F1, F3, config, passwords 137, press F3 parameters. We're already in parameters, so we're already there. Use the arrow keys to navigate to the field labeled 35. So we're going to use F7 to go to the previous table, and we're going to go to 35. Here's 35, and it says right here, right under the box, it says spindle axis 1 through 8, 0 equals disabled. So it is disabled. We'll hit F10 to save for good measure. Configure encoder counts per revolution. The encoders need to be set up for the correct number of counts per revolution. A quadrature encoder line count is multiplied by 4 to get the counts per revolution. For typical Centroid DC servo motors with 2000 line encoders, the correct setting is 8000 counts per rev. High resolution encoders 10,000 line are 40,000 counts per rev. From the main menu, F1, F3, 137, F2 machine, F2 motor. X, Y, Z. Already set to 8000. My encoders are the 2000 line, so I have 8000 counts per rev, so those are all good. Repeat this for each axis to make sure they're all the same. Disable stall detection. Stall detection must be disabled from the PID menu. So we're going to back up. This is good. We'll just hit F10 because it's okay. We'll back all the way back up. Stall detection must be disabled from the PID menu. From the main menu, press F1 setup, F3 config, the password's 137, press F4 PID, and press Control and the V key simultaneously. Stall detection is disabled. You can see it underneath the dialog box where it says Stall detection disabled. Will appear right below the status window. Every time you restart All-in-One DC, you will have to disable the stall detection again. So at this point, we don't want to restart it unless we have to. Next section, clear software ready faults. Anytime the CNC11 software has been exited and restarted without the hardware, that's the All-in-One DC, also being powered off and restarted, the CNC11 will report a software ready fault, as demonstrated below in figure 4.11. A software ready fault like spindle, lube, encoder, and position fault is a stop fault. A stop fault removes power from all servo motors and prevents the program or MDI operation, turns off all drive and spindle enables, and requires the e-stop input must be cycled in order to clear the fault. During the bench test, we will trick the software into thinking we cycled the e-stop, and it's not been wired yet. We just have a board. We don't have an e-stop button wired to the board yet, by toggling input 11. To clear a stop fault, press the Alt-I keys. Let's get out of this, back to the main menu, Alt-I. To bring up the real-time I/O screen, use the arrow keys on the keyboard to select input 11. Okay, if you look down 2/3 of the way down, underneath the last row of LEDs, it says INP11 e-stop OK. Press the Control, Alt, and I keys to toggle the e-stop OK input until it turns red. Control, Alt, I. Okay, it's red. And then press it again until it turns green. There, it's turned green. So we just cycled e-stop. And by the way, remember this, you have to cycle e-stop. If you have an error, you have a fault or something like that, you have to cycle your e-stop button on your machine to get out of it, to reset it. So e-stop cycle is a reset. Okay. Where are we at now? Okay, we've cycled e-stop. Notice as you toggle e-stop OK input to red, that 406, you can see it in the dialog window here, in the displayed, no, it's called a status window. 406 emergency stop detected. So when we turned it, let's do it again, Control Alt I, there it is, 406 emergency stop detected in the status display. Let's cycle it again. Emergency stop released. Okay, so we're there. 335 emergency stop released. So we're good there. Clear any existing faults before beginning bench testing to confirm, and I think that's what we did by cycling the e-stop. Clear any existing faults before beginning bench testing. To confirm that all faults have been cleared before continuing, press F3 MDI. And I think we can turn off the I/O thing, I/O display. If all faults have been cleared correctly, the screen should look like in figure 4.14, and we've got the MDI screen there, and it's clear, and it matches what's in the book here. Troubleshooting tip: CNC11 keeps a log file containing all errors and faults, along with the time and date that these errors occurred at. You can access this log from the main menu. Let's do that. Main menu, F7 Utility, F9 Logs, F1 Errors. And then there's the log. There's my log of all the faults and errors that I've generated. All faults shown in 4.15 as well as other faults are stop faults. Stop faults cancel existing jobs, prevent new jobs from being started, stop the spindle, prevent motion, and require that the e-stop PLC input be cycled, open and closed. So that's, what was it? It's pin 11. We have to cycle that because we don't have a button yet. Open and close to clear the faults before continuing. If you have any stop faults that will have to be removed, then e-stop will have to be toggled as shown in the previous step. That's cycling 11. Alright, let's get out of this. Okay, now we're at the all-in-one DC bench test. Bench testing the all-in-one DC will confirm that the all-in-one DC is operational and that the software has been properly configured to begin the installation process. Bench testing is required as it provides a known base configuration that our support engineers can refer to when trying to diagnose any issues that may arise. To complete the bench test, a DVM voltmeter is required. Okay, our voltmeter, you can see the all-in-one DC and the voltmeter in the display here on your monitor, I should say. To complete bench testing, a DVM digital voltmeter is required. So we have one right here. Set home and load the spindle bench test CNC. Home the machine by pressing start. Okay, the all-in-one DC guide says home the machine by pressing start. Well, you don't know what start is. Unless you have the jog panel, you don't have a start button. The start keyboard strokes are Alt S. So that's what we're going to do. We're going to hit Alt S and watch the display. Alt S. Machine home set. Now we've got what looks to be a normal display. From the main menu, press F2 load. Alright, F2 load. Use the arrow keys to select the file spindle benchtest.cnc. There it is. Now I'll be honest with you, it did not come with my install, and if you look at the install guide, the very next line says if it's not present in the CNCM NC files directory, it can be downloaded here. So I had to go to the Centroid's website and I had to download it. Now we've got it highlighted. We're going to hit F10 to accept. Okay, our DRO's up. Everything looks good. Now we're testing the analog output for the spindle. The all-in-one DC provides a 0 to 10 volt DC analog output to provide programmable spindle speed control using a VFD, variable frequency drive. The default maximum spindle speed specified in the control configuration is 3000 RPM. This configures a control to scale the 0 to 10 volt DC from 0 to 3000 RPM. A spindle command of S15 will therefore output 5 volts. A command of S1000 will output 3.33 volts DC and so on. Set a voltage digital voltmeter to DC, and I am on DC volts, as you can see right here. If you can see it, but I'm on DC volts. And I've set my scale to 30 because we're at 10 volts. Connect the 7-pin terminal block in connector H9. That is up here. I've got it in. Insert the digital voltage meter leads into H9 as shown in figure 4.2.4. Tighten the screw terminals to firmly grip the probes. You will see that I have the DC negative in the first pin, and then I have the DC positive in the second pin, just like the manual shows. With spindle benchtest.cnc loaded, press cycle start, Alt S to begin. Alt S. The following screen will be displayed. You may have to press cycle start twice. Okay, we've got the screen. And it says, welcome to the bench testing utility. Please make sure you have a DVM and a copy of the install manual on hand. Press cycle start to continue. Enter the voltage readings as pictured. Press cycle start to continue. Spindle bench test CNC will throw an error if the spindle does not output as expected. Continue to press cycle start as requested until the program is finished. The program will exit and the status window will say job finished after successful completion. Okay, so we're going to do the Alt S. Alt S. It says voltage reading 1 S500. Enter the voltage DC between the spindle analog and the spindle analog COM. Press cycle start to continue. And we have 1.67 volts, so we're going to enter 1.67 and we're going to hit Alt S to continue. Okay, voltage reading 2 S1000. Enter the voltage DC read between the spindle analog and spindle analog COM. Press cycle start to continue. We have 3.33 volts. 3.33. Alt S. S2000. We have 6.65 volts. 6.65. Alt S. S3000. 9.996. 9.96. 9.96. That's what we've got here. Alt S. Job finished. Well, it looks like we're good after successful completion. Encoder test. Make sure the encoders are connected to the all-in-one DC. Alright, I'm going to hook up my encoders and I'm going to see if I can move my camera back a little bit. Get this out of the way. Alright, let me get my encoders situated here. This is encoder 1, 2, 3, X, Y, Z. So we're going to start with X. Let me get that one. Let's start with Z and we'll work our way that way. There's Z. Here's Y. And here's X. Got an error on the screen, Z idling too high, releasing power. Probably going to have to go into Alt I and cycle that. Control Alt I, Control I. Hopefully that took care of that. Alright. From the main menu, press F1 setup, F3 config, 137. Press F4 PID. Manually spin the shaft of the servo motor counterclockwise as shown in 425. So let's do my Z-axis. Turning it counterclockwise. In the PID menu, confirm that the absolute position counts up as the motor is rotated shown. Repeat for each axis. So it is counting up. Okay, so that's Z. Here's Y. And then I got to reach over so I don't bump the camera. Here's X. Okay, if they're counting up, they were all turned counterclockwise. So another way, so I'm going to go back to Z. I'm going clockwise now. I'm going to show you the number of counts. So if you're unsure of your motor counts, you mark or notate the position of your servo motor spindle. Let's see if I can get it back to 0 as close as I can. It's really touchy. There we go. Okay, so now we're going to turn it. I'm notating the spindle position. I see a slot on the spindle on the encoder pulley. So now I'm going to rotate it counterclockwise 1 full revolution. That's pretty close. And you see that the z-axis is 8,000 counts. So 1 revolution shows 8,000 counts. It's a 200 line encoder. So we should be good there. And that concludes the bench test. So I hopefully it's great to have made it this far and gotten through the bench test. I hope that you guys were as successful if you're setting up an all-in-one DC. And I think the next video will be starting to lay out the electrical cabinet and mounting all this stuff and starting to wire it all.